Here, the TSR-based medium is stable when stored at 4C, protected from light for up to 2 weeks. Basic FTF should only be added to the culture medium immediately prior to addition to your cells at each feeding, and daily feeding is recommended for the system. Once your colonies become dense, large, or overcrowded, such as the representative image shown here, then cells should be passaged. Additionally, cells should be passaged when increased differentiation occurs or when the feeder layer is 2 weeks old to maintain health of your culture. The following images provide some insight into areas for removal during manual cleanup of colonies. The colony on the left has a heterogeneous core, lots of smooth defined border, as well as significant aberrant differentiation highlighted in a red outline. This colony should be removed manually to maintain health of your PSC culture. The image on the right shows a colony with a homogeneous core with some aberrant differentiation occurring on the top of the colony, which should also be removed during manual cleanup. In addition to the aberrant differentiation which can occur on the sides of the colonies, differentiation can also be observed in the center of colonies and should be removed during manual cleanup. 2 examples are shown here. With the far left image showing flattened cells in the middle of the colony, they should be removed. And the figure on the right shows the development of an embroid body in the center of the colony, which should also be removed. Regular cleanup of your KSR-based feeder-dependent cultures is essential to maintain the health and quality of these cultures. In the event that significant aberrant differentiation has occurred throughout your culture and only a small portion of the colonies show normal pluripotent morphology, colonies can be positively selected and transferred to new feeder plates for continued propagation. In the images shown here, we see the progression along this continuum. In the far left, you can see a large amount of aberrant differentiation in the colony circled in red, with a good pluripotent colony shown by the green circle. Upon identifying the undifferentiated colonies, colonies are scored with a syringe needle and subsequently scraped using a pipette tip and transferred to a conditioned feeder plate. If the culture is largely undifferentiated, then areas of differentiation should be removed and cells should be passaged using the methods highlighted on the following slide. For bulk passaging of undifferentiated pluripotent stem cells, there are manual or enzymatic options available. For manual passaging, we recommend the use of the StemPro Easy Passage Disposable Stem Cell Passaging Tool. This tool provides a quick and efficient manual passaging method which provides consistency and uniformity of size of colony clusters. Following manual cleanup of differentiated colonies and subsequent washing for the removal, the Easy Passage tool is ran in one direction along the plate in rows, and then turned 90 degrees and ran across the plate again in rows. On the top right is a representative image showing the consistency of rediment sizes produced using this tool. Cells are then gently scraped from the surface of the plate and transferred to a new plate, generally at a 1:3 to 1:6 split ratio. Alternatively, bulk passaging can be performed via the treatment of undifferentiated PSCs with either collagenase 4 for 30 to 60 minutes at 37C or disphase 2 treatment for 5 to 15 minutes at 37C. Incubation with these enzymes should be stopped when the colony edges begin to peel from the plate. Cells are then subsequently triturated to break up the colonies into small clusters of 50 to 500 cells for propagation. We will now move on to review the 2 feeder-free pluripotent stem cell culture systems available from Thermo Fisher Scientific. The first feeder-free PSC culture system that was launched by Thermo Fisher Scientific was the StemPro HESC SFN system. This system is a fully defined CN-free system which is provided as a medium containing supplements, a bovine serum albumin additive, and a basal medium. Much like the KSR-based medium, additional medium components are required, including 2-mercaptoethanol as well as FTF basic. Cells cultured in this medium system are seated onto Deltrix matrix and routinely passaged using collagenase 4 incubation for 3 to 5 minutes. The image in the lower left shows representative morphology of pluripotent stem cells cultured in the StemPro HESC SFN system, showing a homogeneous core and high nucleotidyl-cytoplasmic ratio of the PSC. Looking at the workflow for StemPro HESC SFN medium cultures, plates are initially coated with Deltrix. PSCs are then seeded onto the Deltrix in the presence of StemPro HESC SFN. Routine manual cleanup of the cultures is carried out with removal of differentiated areas like that discussed for the KSR-based system, and finally cells are passaged. Here we will cover some important considerations for working with the system to help you ensure successful PSC culture. For matrix considerations of working with Deltrix, the Deltrix solution should be thawed overnight at 4 degrees C. When working with Deltrix, it is imperative to keep it chilled to prevent polymerization. Therefore, Deltrix should be transferred on ice from a 4C refrigerator and diluted into pre-chilled DMA-12. A dilution of 1 to 100 is recommended for PSC cultures. Much like the KSR-based medium, the stability of StemPro HESC SFN, excluding the addition of the FTF basic, is 14 days at 4C. Medium should be discarded past this time. Immediately prior to addition of to the cells, FTF basic should be added to the culture medium. It is recommended to passage the cells when they become overcrowded or too large. Finally, we will cover the properties of the essential-8 medium. This system is further streamlined to ensure consistent performance and is a xeno-free, feeder-free culture medium system. The essential-8 medium comes as a complete formulation comprised of a basal medium and supplement and does not require the addition of other media components. There are multiple offerings for matrices that can be coupled with the essential-8 medium system depending on your application and system needs. There are 2 xeno-free matrices, that we offer, including a fragment of recombinant human vitrectin and full-length recombinant human laminin 521, which are both recombinantly expressed. The xeno-free system is not required, and the cells can be cultured on gel-track substrate as well. Depending on your downstream application of interest, two processing reagents are commonly used with the system. Protein, an EDTA solution, is used for routine culture of pluripotent stem cells. For applications in which cells need to be singularized, such as in high-throughput screening or differentiation protocols, cells can be passaged using triple select. On the next slide, we will review the properties of the various matrices to assist you in your selection. Looking at the workflow for essential medium cultures, which are initially coated with extracellular matrix of interest, the pluripotent stem cells are then seeded onto the ECM in the presence of essential medium, and cultures are maintained by daily feeding. The cultures do not require manual cleanup of differentiated areas prior to passaging. The table provided below will assist you in identifying the appropriate matrix to fulfill your workflow needs. As mentioned earlier, if a defined surface is required, the recombinant human vitrectin or recombinant human laminin 521 should be used. Always keep in mind the thaw temperature, stability, and diluent for each of the systems as well to ensure matrix integrity. Initial coating concentrations are provided that may need to be optimized